Hi everyone, it's Justin again. In the last video, you learned how to simplify roots, whether they just contained numbers or also included variables. But roots aren't always by themselves. Sometimes they're part of larger expressions. In this video, you're going to learn how to simplify square roots even with other numbers and variables around them. You learned in the last video that simplifying roots is the same no matter whether it includes variables or not. Factor whatever is inside the radical, pull out groups, depending on what kind of root it is, then multiply all the factors inside and all the factors outside. This process will be the same even with expressions, with a couple small changes. Instead of just multiplying the factors that were pulled out, we now have to multiply all the coefficients outside of the radical. This is because with expressions, there are sometimes already values multiplying the root. Another small change is that sometimes an expression will multiply two roots together. So we have to combine them and then multiply everything in both. These changes might seem a little confusing just in words, but they're easy to do. Let's try some examples and see for ourselves. Let's start with an easy one. Two roots being multiplied. First, we need to simplify both roots. The first one has no pairs, so it can't be simplified. But the second one can be. 4 is 2 times 2, so we can pull out a 2. With 5 x's, we can pull out 2 pairs, and we don't have enough y's for a pair. The parts still left in the radical are an x and a y. Normally, we would need to multiply all the coefficients, but in this example, that's already been done. Now, combine everything inside the radicals and multiply. We get 2x squared y squared. Do you notice anything weird? Now we've got another pair of x's and another pair of y's in the radical. So we can pull them out and multiply them into the rest of the coefficients. So we actually end up with 2x cubed y times the square root of 2. Having to simplify then re-simplify that last problem can be a little annoying. So let me show you a way to avoid that. To keep from pulling out pairs, combining the radicals, and then having to pull out pairs again, we can just combine them right from the start. When we multiply everything through, we get 8x to the 6th y squared. Now everything is already under one radical and ready to be paired the first time. 8 is 2 times 2 times 2, so we can pull out a pair and leave one under the radical. 6 x's means we can have 3 pairs, and we're left with a single pair of y's. So the simplified form comes out to 2x cubed y times the square root of 2, which is the same thing as before, except with way fewer steps. Combine first, simplify after. Let's make it a little harder by putting in some coefficients. If we simplify, then combine, we might end up with more pairs that can be pulled out from the beginning. So let's use that shortcut we just learned. Combine the coefficients and combine the radicals. Now we'll only need to simplify once. Inside the radical, let's factor 27 into 3 times 3 times 3. Now we factor out pairs. We have a pair of 3's, which leaves a 3 under the radical, 2 pairs of y's with 1 y left over, and only 1 z. So that has to stay in the radical with the rest. Now that we've pulled out everything possible, we just need to multiply. 2 times 5 times 3 is 30 times y squared times that z with 3yz left in the radical. So the simplified form of this expression is 30y squared z times the square root of 3yz. Let's try adding some new operations in. Since exponents and roots are based on multiplying, only multiplication and division can affect a root. Adding and subtracting can't do anything with a root or its coefficients, except in very special cases. All we can do here is just simplify this root expression. We're done. We can't simplify the addition or subtraction. We ruled out addition and subtraction, but not division. Since division is just inverse multiplication, it can also affect roots. Take this expression, for example. We treat division just like multiplication. Coefficients go together, and the parts inside radicals combine into one giant one. Now we just perform the divisions. 10ab cubed divided by 2b is 5ab squared. And underneath that radical, 6a squared b divided by 3a squared is 2b. b. So remember, combine coefficients and roots, then simplify, but only when there's multiplication and division. With this knowledge, you've now finished with the exponents and radicals unit. In the next unit, we're going to look at one of the most common real-world examples of exponents, exponential growth and decay. See you then.